Hi, everyone. Thank you so much for being here. My name is Nikita, and I'm a developer advocate for Google Cloud. And today I'm really excited to show you how you can measure, report, and reduce your carbon emissions from IT operations if you're using Google Cloud. Specifically, we're going to look at three tools in the Google Cloud Console. There's Carbon Footprint, Region Picker, and Active Assist. But before we do that, it's important to just get some context. So I want to start with the source of energy that powers compute resources in the cloud in our data centers. Electricity is produced by power plants, which operate on a particular regional grid. So these power plants can be sourcing in energy from a combination of carbon emitting fossil fuels like gas or coal, as well as non-carbon emitting sources like wind or solar. And different regional electric grids have different makeups of power sources depending on what's available. So carbon emissions from the grid will vary depending on, where the electricity is being sourced from, as well as the actual time of day. Since 2017, Google has matched 100% of its global energy use by purchasing renewable energy and has mitigated the annual carbon footprint of our customers' digital applications and infrastructure. But we're currently working on the ambitious goal of operating all of our data centers, which is the backbone of our compute resources, to be powered 100% of the time on energy that's carbon-free by 2030. So what this means is that every hour of every day in every region where we operate will meet our energy demand with the supply of non-carbon emitting energy. However, the best energy saved is, of course, the energy, not consumed in the first place. So for over a decade, we've been working to make Google data centers some of the most efficient in the world. Power usage effectiveness, or PUE, is a standard way to measure data center computing efficiency. You calculate PUE by taking the total energy that's used in the data center divided by the energy that's only used for computing. So basically what this number tells you is for every watt of energy used for computing, how much extra is needed for the facilities, the cooling, and all that other stuff. And Google data centers only need an additional 11% for that everything else bucket. So you as a user, if you're using Google Cloud, you can take advantage of that efficiency compared to the industry standard of a PUE of 1.67. So with all that context, the question arises, how can you measure and minimize your carbon emissions from your IT operations? For starters, it's really helpful to understand where your electricity comes from. I think it's very easy to be kind of distanced or displaced from this idea of, what is the source of the electricity that we're using? But like I mentioned earlier, the carbon emissions really will differ based on the time of day and then also based on your location. So our partner, Electricity Map, provides a free dashboard that enables you to see where your electricity actually comes from based on your location on an hourly basis across over 50 countries. So you can see a screenshot here from their actual app, which I've linked down in the bottom here, and highly recommend you go and check it out. You can go and see for your location, what does that electricity mix actually look like at that particular time? And once you have a sense for, where your electricity is coming from, the next step is to calculate your organization's specific carbon IT emissions. And for this, if you are a Google Cloud customer, you can leverage the out-of-the-box carbon footprint dashboard directly in the Cloud Console. This tool includes charts and tables on total emissions by project, by month, by product, by region, etc. And you can also optionally export all of the data to BigQuery and perform any kind of custom analytics and visualizations. This is what I personally do. I work in a set of projects that are under a billing group with other teammates. And so I go into this data, I export it to BigQuery. And with a couple of SQL commands, I can see across all of my projects, which products am I using the most carbon for. And you can actually use all this data for sustainability reporting of Scope 3 emissions, all within the greenhouse gases auditing framework. So if you're unfamiliar, there are these 3 emission categories at this time called Scope 1, 2, and 3 to help enterprises measure their carbon impact. scopes 1 and 2 relate directly to emissions that are specifically controlled by an organization. And scope 3 are the organization's indirect emissions, like the supplier's activities or consumers' product usage or effects from transportation and waste disposal, just to name a few. So once we have all of our own carbon data, right, like step 1 is to just understand where our electricity is coming from, get access to our actual carbon data. And once we have that, we can start diving into some strategies for actually reducing the carbon emissions in our Google Cloud infrastructure. And the easiest and most impactful reducer of emissions comes from selecting regions that are powered by cleaner energy in your Google Cloud projects. So you're already used to selecting compute regions based on requirements of, data locality and price or latency. These are, the factors you're probably already looking at when you go to select a compute region. But generally speaking, we don't think about adding carbon to that list, but it's actually incredibly important because each region can have a significantly different carbon emissions profile. And because of this, Google introduced a metric called the carbon free energy percent, or CFE, to enable users to select regions with higher CFE percentages because they produce fewer carbon emissions. So as you can see here, the CFE score can vary greatly between regions, even between some that may be relatively close in proximity. So for example, if you were to move a workload from Salt Lake City, which has a CFE of 28%, over to Oregon, which has a CFE of 90%, you can significantly reduce your IT carbon emissions from that workload. In our product docs, you can find a table that will show the average Google carbon-free energy, the CFE percentage, as well as the average annual grid carbon intensity for every single region in Google Cloud. And then in many of our products, when you go in to choose a region, there's also this friendly low CO2 icon directly in the Cloud Console. So on the left side here, you can see an example from the Cloud Run service. And if you're going to create a new service, when you go to select the region, you can actually see the regions that are annotated with the low CO2 icon as an option for one that you can select. And this icon is also annotated in the location section in many of our product documentation pages, but it's especially helpful when you can see it just directly there in the Cloud Console and you don't need to go back and reference the documentation. But of course, in reality, we have to consider more than just carbon when we're picking a region. So if you're looking for proactive advice on what regions to use, you can try out a tool called the Region Picker, which helps you to compare priorities around lowering emissions versus pricing versus latency. So you can see on the menu on the left side over here, you select your where your traffic is coming from, and then you can toggle the bars for carbon footprint, lower price, or lower latency, depending on kind of what your priorities are, and it will recommend the best regions for you, given those parameters. So for example, you can learn that by moving a workload from London to Finland, you can increase the carbon-free energy percent by 23 and actually lower your price by 14%. And if your organization provides users with the choice to select regions for their compute resources, you can actually set organizational policies to completely restrict locations to low carbon intensive regions using something called low carbon mode. Or you can allow or deny specific regions in the policy value box when you're configuring the resource location restriction. So the way you do this is you enter the in prefix and then a specific string for one or multiple low carbon locations. The next recommendation is to avoid running resources 24 hours a day, especially for development and testing. And so, for example, if you shift resources to operate 10 hours a day during 5 work days a week instead of 24 hours, you can reduce your footprint by 70%, which is impactful both from a cost perspective and then also from a carbon perspective as well. And on the same topic of scheduling, you can also program your workloads to run during the day when there's more clean energy available, like solar or wind. So not just thinking about going home, running that long batch workload or that batch job right before you go to sleep, but thinking about how you can reschedule these workloads to happen during the day when there is more clean energy available. So for example, if you check the energy mix in the UK using Electricity Map, which is that tool I mentioned earlier, at 7 p.m., you'll see it shows, 284 grams of carbon dioxide equivalent per kilowatt hour of electricity. However, executing that same workload earlier in the day, maybe 1 p.m., you can see that it's just 200 grams. So 284 grams versus 200 grams if you were to schedule it earlier in the day. So by shifting these workloads that may have operated at night to run earlier, like 1 p.m., you can actually reduce your carbon emissions by up to 29%. In addition to intentionally, shortening resource schedules, you can also proactively delete unused VMs, optimize VM shapes, and also shut down inactive projects and just resources in general. So the Active Assist tool is one that proactively suggests carbon reducing configurations along with other cost and security friendly actions. It's a product that's really designed to help you manage the complexity of cloud and kind of keep track of all of your cloud resources. And one of the categories it provides recommendations under is sustainability. So finally, there are also a few different low carbon architecture designs that you can use, and I'll cover just a couple of them today. And the first is to use managed serverless products, which helps you by leveraging their separation and storage and compute resources, enabling you to use the same storage space while still auto-scaling VMs up or down based on traffic. This also prevents incurring compute or storage costs from idle resources. So I know personally, when I went and first started looking into the carbon data in my own projects that I was using on Google Cloud, one of the biggest sources of carbon for me in my footprint was from idle VMs that I had just run for like a demo or a lab and just left running and forgotten about them. And the more I'm moving over to using these fully serverless products, it's so nice to not even have to think about going in and shutting down all these resources that I'm not using anymore. And also by refactoring monolithic applications into bite-sized microservices, you can gain a lot of efficiency benefits. This is because microservices operate as these self-contained modular functions. They have less dependencies. They're easier to maintain and debug and offer more granular control over resource scaling and just generally less tests. So in summary, wherever you are on your sustainability journey, you have tools available to you that you can use in Google Cloud, like Carbon Footprint, the Region Picker, or Active Assist, which are all available out of the box, and you can try them out today. But if you only remember just one thing from today, from what I've said, the best way to reduce your day-to-day carbon footprint is by proactively choosing to operate in regions with the lowest carbon intensity. So thank you so much for tuning in today, and best of luck on your sustainability journey.